Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called Find Minimum in Rotated Sorted Array. We have an array of length n sorted in ascending order and it was rotated between 1 and n times. So basically if we have an original array like this, if we rotate it 4 times, this 0 will go 1, 2, 3, 4 times to here. Okay, so that's the result of this rotation. And if we rotate it for 7 times, it's the length of the array. So we got the original array as well. And yeah, so that's basically it. And given the sorted rotated array nums of unique elements, return the minimum element of the array. And we are asked to write a log n algorithm. So basically it's telling us we have to use binary search. Yeah, so that's pretty clear. I think everything's about the same. So how should we find the minimum using only binary search? So as we know, if we want to find a target in a series of numbers, which is sorted, we can use binary search. But this is a rotated binary search, so we have to figure out how to do it. Basically, we have a left pointer and a right pointer, and this is the middle pointer. So first, we can compare this with the adjacent elements. Okay, so if this one is larger than the next element, so the minimum should be this one, right? Because if in the middle it was sorted, okay, it was sorted, but this middle is larger than its next element, so we know immediately that this is the smallest one. Okay, and if, let's see here, we got the same thing, left pointer, right pointer, and this is the middle pointer. This one is larger than its next element, so the next element would be the smallest element in this rotated array. Okay, and any other stuff? So maybe let's think, if we did not land here, let's say we have something like, let's say we have something like 4, 5, 6, 0, 1, 2, maybe 3, like that. So the middle would be here, right? The middle will be pointing at 0. So here we cannot use 0 to compare to its next element. And now, in contrast, we compare it with the previous one. So if the previous one is larger than our current one, our current middle pointer is pointing to the smallest element in this array. Okay? And also there are other variations. Let's say if we have some, so the first scenario, only one element. So we can just return nums 0. Okay, that's the first scenario. And second scenario is not rotated. So in this case, we can just return nums 0, but we have to judge whether it's not rotated or not. So how do we judge if one is rotated or not? We can compare the first element and the last element. If it's sorted, the last element will always be larger than the first element. Okay, so we can use this to judge, which is if nums right is larger than nums 0. Okay, in this case we can return 0. All right, and next we enter into our classic binary search. So here we have to compare nums mid with nums mid plus 1. Like I said, if this is the case, we know immediately that we are going to return nums m plus 1. Okay, next we compare nums minus m minus 1 plus, to nums m. In this case, we're going to return nums m because, like I said in the previous example here, okay? And after that, I think these are the corner cases. So for regular ones, how should we compare the binary search? So basically we can compare the middle with nums 0. Okay, so if we know that nums mid is larger than nums 0, we know immediately that this is the second half part, which is the larger part of the whole sorted array. Okay, so in that case, we can't go this way. We have to go to right to find the smallest element. Otherwise, if like the middle is smaller than nums 0, okay, let's take a look at an example here. So let's say we have, oh yeah, this one is this is the same one. So if the middle is smaller than that one, that means this part is sorted and it's guaranteed to be larger than the smallest element. So we have to go left. Okay, so in this case, if nums middle is larger than nums 0, we're going to move our left pointer to the right. Okay, else, okay, we're going to move our right pointer to left, to the middle. Okay, to the left of the middle. Okay, so, and if nothing happens, if there's nothing in this sorted array, we can just return something illegal. Okay, so if it's illegal, we can return something like -1, integer max value, something like that. Okay, now let's code it out. So first we have to check if nums.length equals to 1, there will be only one element. We can just return num 0. Okay, next we're going to initialize our binary search. And we have to do some check for not rotating. If nums r is larger than nums 0, return nums 0. Okay, not rotated. And now enter our binary search. We have a middle, which is right minus left minus 2, divided by 2. So if nums middle is larger than nums mid plus 1, that means our nums m plus 1 is the final answer. Okay, next, if nums m is larger than is less than, no, m minus 1, yeah, is larger than nums m, that means we are standing at the minimum element. Okay, other than that, we're going to nums middle is larger than 0. That means this first part is sorted, so we have to find the minimum in the second half. So left equals to minus plus 1, else right equals m minus 1. Okay, we can return an integer max value. Okay, so that's basically this problem. Let's see if it passes. Okay, I think that goes correctly. So time complexity wise, it will be log n. And for space complexity, we're not using any other extra data structures. So it will be a constant time. Okay, let's submit it. Okay, good, perfect. It passes all the test cases. Thank you so much for watching, and if you like the video, please like it and subscribe to my channel. I'll see you in our next video.